welcome everyone. And for those who are watching this later in the future, welcome you too. Today we have the honor of hosting Marine Carpuat. She's a professor at the Department of CS at University of Maryland, and congrats for the recent promotion. So she's now like the highest official rank that a professor can achieve, which is like a huge achievement and, very well deserved. Her research focuses on developing AI techniques that help people communicate across languages and studying whether those systems actually succeed. So this is a quote from her webpage, and I love that you're able to put your research in like that very powerful, very succinct sentence. So I think we'll hear a lot about that today. So her work spans foundational NLP methods, as well as evaluation methodology and human-centered studies of how people perceive and rely on AI-generated translations. Before joining the University of Maryland, she was a research officer at the National Research Council in Canada, and she received her PhD from the Hong Kong University of Science and Technology and a diplôme d'ingénieur from the French Grande École Supérieure. So I think also it's a really international research career. I'm actually curious if that also might have biased or inspired some of your multilingual, multicultural interests of research. She's published extensively at many NLP venues and also in human-computer interaction venues. And I can say that I have loved and admired her papers since I was in my PhD when I was working at MT, because there's always a novel and interesting perspective, a new question being raised, and like she really has the eye to put on what others might miss, and like also developing evaluation methodology that might capture that. Today she's going to be talking about her research and research of her group titled From Machine Translation to AI-Mediated Communication. I find this particularly interesting because it takes AI models outside of the little lab environment box that we developers like to get comfortable in, and then really evaluating them out in the real world, but still applying this kind of same rigorous evaluation methodology without being afraid of like bigger questions of impact and, do things actually work? Where do they fail? And this kind of change of methodology that this also brings. So I'm very curious and excited to hear what she's going to have to present to us today. And we'll have 1 hour in total. There's going to be plenty of time for questions. If they're very urgent clarification questions, put them in the chat and I'll try to interrupt when it's appropriate. Otherwise, we'll have a lot of time for discussions afterwards. So thank you again, Marine, and the stage is yours.
Thank you so much, Julia, for this very warm welcome. It's really a pleasure for me to be here today. My work, as Julia pointed out, I've often found myself or put myself in situations where there was language and cultural barriers. And this informs my research as well, right, where I'm focused on figuring out how we can use these AI tools that are increasingly better, these multilingual tools, to help people communicate better. And I'm particularly excited to be having this conversation here because I think Cohere has done a lot of work in taking multilinguality seriously as a core component of building AI models, and not as an afterthought. And this is something I particularly appreciate. So Julia did an excellent job of summarizing my main research interests. The key question that drives my research today is figuring out, when we use AI to mediate communication, particularly across language, how can we get it to really help people understand each other? And so what I'm going to do today is give you a kind of a case study of the work we've done, starting in machine translation, which is where I started 20 years ago now, and moving towards cross-cultural understanding. I'm going to focus on the story that connects the individual papers. So that means that I'm not going to deep dive much into any of them. But of course, I'm happy to talk about details in questions or later if you're interested. All right, so let's start with translation, right? So, as I said, I started in machine translation, so I'm biased, but I like to think of machine translation as the original generative AI application. Through decades of obsession with evaluation and control benchmarks, we've seen a lot of technical contributions and many of them are fundamental building blocks of large language models today, from neural language models to attention to subword tokenization, synthetic data generation, reinforcement learning for human feedback, which was Julia's dissertation, way before this was an acronym that we can now use as a verb. So there's been like a lot of technical progress that's been really useful and has made it possible to develop online apps that have been available for decades, more than 20 years now for apps like Google Translate, and millions of people use it in their daily lives. And that's really impressive and really cool. At the same time, I think there's the social technical gap between how the technology is developed and how it's used in real world contexts is not narrowing, it's growing. Now that translation is embedded in multilingual chatbots, there are even more users and even more use cases, but their needs and the use cases do not directly inform the development of the technology. So a question that I've been asking, the reason this matters is that when translations go wrong, it has real world consequences. And there's so many that have been documented over the years. This is one of my favorite examples from a while back now, but it's an example like here, it's just inconvenience, right? Translation error, you just got way more eggs than you intended to order. Sometimes the consequences are more serious, where incorrectly translated terms, in this case, a term incorrectly translated as an insult, prompted a fight that ended badly. We have evidence that inconsistencies in automatic translations have jeopardized immigration cases in the US. And there's so many such examples that there was this article by Slate a few years ago titled Death by Machine Translation. Thankfully, death remains rare, but the harms caused by machine translation are real. And a question that's been driving my research for the past 5-ish years is what can we do as technical people to address this problem, right? As a field, we've focused on improving output quality, and that's really important, and we should keep doing that, particularly taking into account languages beyond high-resource languages, translations that does not involve English. There's clearly a lot of work to do in that space. And at the same time, while we should keep doing, working on improving translation quality and multilingual AI quality, I think it's important to also ask ourselves, how can we support people to use these tools to support communication, even as the outputs remain inherently imperfect with hallucinations, mistranslations, and all the things that come with AI tools? So the core problem in this setting is that the users who stand to benefit the most from AI translation and multilingual AI in general cannot verify its outputs, right? If everyone was bilingual or multilingual in all the languages of the world, then we wouldn't need these tools. But it is the people who are not bilingual who stand to benefit the most from using them. But at the same time, they're not equipped to verify whether the outputs are correct or not. And so this matters in translation and multilingual settings, of course, but I think this is also the case in many use cases of AI agents when we use AI agents these days. And so I think there's probably lessons to draw from what we're seeing in cross-lingual communication settings. So let me make things a bit more concrete. Right? Consider this scenario, like imagine you're a doctor, you're in an emergency room, maybe in the US or in an English-speaking country, and you need to discharge a patient who only speaks Mandarin Chinese. Today, and for a while now, doctors use translation apps like Google Translate to translate discharge instruction into Chinese under the assumption that showing the patient something is better than just giving them English they can't understand. And that's nice to have these tools. But the problem, of course, is that the translation is not always correct. And previous studies have found that errors in these very practical scenarios can have clinical consequences. So in this case, the Chinese version tells the patient to keep taking a medicine while the doctor meant the opposite. So clearly there's a meaning error, an adequacy, a quality error that we need to fix and build models that are able to produce better translations. That's one kind of error. But there's also other issues with this interaction. One is that the errors are hard to identify. The patient is looking at a very nicely fluent output, so they might not be able to know that there's something wrong. And also, there's just no actionable strategy to help people recover. They're just left alone with this output and have no support to find out that there's something wrong and help them recover. So this motivated a line of work where we tried to figure out how can we help physicians, in this case, decide whether a translation is good enough to share. The strategy that people use today is back translation, where they take the output, translate it back using the same tool, and use that to get some signal on how good the translation is. The problem is that this is super noisy, right? It could be that the additional translation path fixes some errors that were in the original translation or introduces some new ones. Just to make the point that this is a very unreliable signal, we entered this method, back translation, with some kind of similarity metric in a translation evaluation benchmark. It did worse than the baseline. So, not a good idea, but people do that a lot in practice. Doctors do that. Sometimes they even train to do that. And we know people do that in many use cases. So, we thought, well, let's see what happens if we actually evaluate this strategy that people use in practice. At the same time, I thought, well, there's just a lot of research that we can build on from machine translation and multilingual NLP, where we can do a lot better than back translation. Through decades of research, we have tools that can automatically evaluate translation quality, which these days are essentially multilingual language models fine-tuned on human ratings of translation quality, and they do great on benchmarks. So we thought we could use these tools to automatically evaluate the translations we get and show the ratings to doctors. We don't show them the raw rating because they're kind of hard to interpret. Like, what if you get a 0.43 versus a 0.67? So we converted those to 3 levels ratings for readability. And we ran a user study where we showed doctors translations and asked them 2 questions. Would you give it to a patient who only reads Chinese? And how confident are you in your decision? We asked them this question first without any support, and then either with quality estimation feedback or with back translation feedback. What we found at first made sense. We found here that with the quality estimation feedback, so the fine-tuned large language models, physicians made better decisions in dark blue about when to rely on the translation compared to when they had no feedback in light blue. And when they were showed back translation, that didn't make any difference, right? That's kind of what we expected. So good news. However, if we drill a little bit more and separate out, same chart, but splitting out the translations that are adequate, that are correct, that are actually good idea to share with patients on the left, and the ones that contain errors on the right, we see a different picture. What we see is that the quality estimation feedback actually helps physicians when the translations are good. They make good decisions on the good translations. And that's fine, but what we really care about is helping them make good decisions where the translation are bad and might have a clinical impact on patients. And in that case, quality estimation actually doesn't help. And back translation that I told you earlier seemed like such a bad idea actually helps them make better decision, although not better than baseline. Not statistically significantly better than baseline. So that study was really eye-opening for me, and really led me to think about, well, how can we actually help people rely on imperfect AI outputs here, translations, right? Clearly, what people do by default, back translation, and the tools we have that are designed to evaluate translation quality for benchmarks kind of in a vacuum don't actually help people in practice. So what else can we do? So we went back to the drawing board and came up with the idea of using questions and answers to highlight inconsistencies between the original message and the translation, as a way to help people weigh the risks of misunderstandings and not just give them a score or just a quality rating. Let them make their own decision. This is motivated by several lines of work, including, in more like NLP settings, the use of comprehension tasks as extrinsic evaluation of generation, as well as work in psychology that looks at how humans think of explanations and distinguishes between functional explanations that are more focused on the consequences, the impact of a particular mechanism, as opposed to mechanistic interpretation that focuses more on what went wrong, right? So in this case, it's more focusing about, with question and answer, what is the nature of the misunderstanding or the miscommunication and how might it impact people in practice, as opposed to what is the translation error and what went wrong in the translation process. And we also like this kind of approach of asking and answering question because it aligns with real-world communication practices. In the case of doctor-patient communication, we know that doctors are trained to ask questions to verify that the patient understood what they're supposed to do. For instance, what symptoms should you look for to decide whether you should come back to the ER or whether you should just wait at home, that kind of thing. So we decided to, instead of like fine-tuning models to produce ratings of quality, to use language models to automatically generate questions on the basis of the original message and automatically answer them on the basis of the original message as a reference and of the translation output, and compare these answers to surface any problems. So, this can be done with LLMs today, but as you can expect, like a naive approach where you just prompt a model to generate questions on the basis of a message is just not generate good and useful questions. So we had to give quite a bit of thought on how to structure the question generation. What we ended up with is something where we first automatically extracted facts from the original message, did a filtering stage based on entailment to make sure that the facts were actually entailed by the original message, not hallucinated, and then generated questions on the basis of the remaining facts. So now for every original message, we have a bunch of questions, and we answer these questions first on the basis of the original message and on the basis of the translation, right? And what we're looking for is having the same answers to the same questions, and if they're inconsistent answer, that's where what we view as a signal of a problem. So, we can do question answering with large language models today. The wrinkle here is that, of course, the translation is in a different language than the source message by definition. And so we need to do question answering in a cross-lingual setting. There are many ways we could bridge the language gap. What we ended up doing is back translating the translation into the source language. Empirically, it turns out that this is what works better compared to, translating the question or translating the answer or doing cross-lingual QA. But I also like it from a human-centered perspective because we can think of it as adding a layer of support with the questions and the answers on top of what people naturally and intuitively do, which is use the back translation. And here we're using all this question generation and answering layer on top to help them focus on the things that matter, right? And so now when we have answers, and we want to compare them, well, we can just show them to people, but we can also have some automatic comparisons with various similarity metrics to compare the answers that we can then aggregate. So first, we validated this on synthetic data, where we automatically injected errors of different severities into translations that were good. And what we see is that this approach helps us penalize the errors that are more critical more than the errors that are more minor, that are just kind of, different ways of expressing the same things or minor omissions, as opposed to major alterations in meaning. So that was encouraging. We also evaluated this on standard benchmarks like this biomedical quality estimation task, where we found that our approach, when using an automatic similarity metric to aggregate the differences between answers, gives us correlation with human ratings that are on par with supervised models that are fine-tuned on human ratings. So that was pretty encouraging. You'll notice that the correlations are remain low. This is a kind of hard out of domain task. But here, like, we're encouraged by the fact that we're taking a completely different approach than the typical supervised fine tuning, and we're getting comparable results. But what we're really interested in is like what actually happens when you show this to people. And so that's the study we ran next. Right, we're here. We are similar to what we were doing with doctors, except we haven't done this with doctors yet. Doctors are quite expensive, so we started with a crowd first. We show people text that is still in the health domain. That's kind of all COVID guidance related, translations into a language that is Spanish, actually, in the experiment. And then we ask people, like, do you think this translation is good enough to share as is? And how confident are you in your decision? Now, in this study, this was a few years later, so we had a few different other tools at our disposals in terms of the kind of feedback we can provide to people. So we still use back translation. We use the question and answers that I just told you about, and we think of these as kind of implicit ways of evaluating quality. We don't explicitly rate quality, but we give people support. And then we compare that with more explicit quality assessment, including highlighting of errors automatically generated with dedicated fine-tuned models, and also LLM explanations of translation quality, right? We can prompt multilingual LLMs to assess translation, and with a little bit of scaffolding, they can be actually pretty good at evaluating translation quality. Not in all languages, but for the high resource languages we're working with here, they're pretty good. So we thought, well, what if we just show people these LLM explanations? So in these settings, what we found is that all the feedback types except the error highlights actually improve people's decision accuracy, and compared to having no access to no feedback at all. So that's encouraging. For the highlights, I think what's happening here is that we're providing highlights in the target language, which is a language people don't speak. So that's not super helpful. Having information in their language, like the explanation, the back translation, and the QA table, it is much more beneficial. And the question answering table yields the greatest gains in the decision accuracy and the confidence weighted accuracy metrics. I think what's more interesting to me is this, where we kind of try to break down how feedback impacts decision, right? So in this setting, we first ask people to make the decision without any feedback, and then we feedback. And so we can see how their decision changes. And what we want to avoid is the cases where they had a good decision initially without feedback, and then in the presence of feedback, they changed to the wrong decision. So that's over-reliance in dark red here. Or cases of under-reliance where they were making the wrong decision initially, and then even with useful feedback, they're just not able to switch to the good decision. And so what we see here in this study is that the implicit kinds of feedback, so back translation and the question answering table, have smaller rates of over-reliance, right? So people do not just blindly follow the AI recommendation and like stick to their guns if they had like a good decision initially more. And at the same time, the QA table does better than back translation in under-reliance, like the not relying on the AI output when it could actually be useful. To get an intuition for why that's the case, I think it's really informative to look at some of the qualitative feedback that we got from the participants. I particularly like this distinction between what people told us, when they had access to the LLM explanation, which they liked. Like they like all the feedback types because otherwise they're just left alone. So no matter what, they like it. It's just like in some cases that they make better decisions than others. And in the case of LLM explanation, people said, oh, it was great. It gave me the answers. So, that's kind of the definition of reliance. They just think the AI gives them the answer and just go with that. By contrast, when people had the access to the question and answer table, we had answers in the first person where people said, I could compare the words and make determinations. So really showing that, people had more agency in making their decisions as opposed to just going with whatever the feedback tell them to do. All right, so here I see this line of work, this framework that we're calling AskQE, this question generation answering framework, as a promising way of thinking about how we can support appropriate reliance in translation and more generally AI-mediated communication. It can distinguish critical from minor errors and provides interpretable and actionable feedback for decision making. This is by no means a sole problem. There's so many open questions that we still need to address in this space, right? Like the whole design of the question generation and answering framework can be improved. The efficiency, like there's like many calls to making this happen. So I think like hybrid approaches with some of the supervised models could be useful here to guide the question generation. We've only tested this in one use case, like what kinds of questions are useful depending on the use cases, going beyond factoid questions and so on, like are things that deserve a lot more attention. But I'm excited about this line of work because to me, it illustrates like kind of the path towards answering the question I was asking at the beginning, where we're moving from focusing on the translation task, kind of transducing text in one language into a sequence of tokens in another language, to thinking about how we can support AI mediating communication. What we're seeing is that there's a real communication gap, right? Even with great tools that score well on benchmarks, there's still harmful errors, and it's very hard for people to decide when to rely on translations. Using human-centered methods reveal what benchmarks miss. User studies can help show which kind of feedbacks help. And for me, as a person who's comes more from the technical side, like I learned a lot from my HCI collaborators, but at the core, what I want to do is technical work. And this kind of human-centered evaluation helped me figure out what are the tasks that are useful to solve. And here it led me to reframing translation quality estimation as question generation and answering. I think another thing that I want to highlight is that this kind of work is really iterative, slow, requires a lot of different kinds of evaluations. So, to make these concrete, like what I've just described, is published in these 3 papers, starting like the first physician studies is from 2023, which, in these day and age is like such a long time ago, and it's only in 2 years later in 2025 that we published like the question generation and answering, and we're still working on closing the loop with actually running these studies with doctors. So it's slower, but I think it's worthwhile, and these are like really enjoyable interdisciplinary collaborations with folks in computer science and med school and information studies. So I've talked a lot about the high stakes settings like doctor-patient clinical settings, but at the same time, AI tools are used to mediate communication in very casual settings as well. And I think these are, the stakes are different, but they're equally important. And we've done some work as well in thinking about how we can support more reliable communication in these casual settings. In particular, we ran a study at a museum here in Washington, D.C., the Planet Word Museum, which is a museum about language, which is really fun. If you're ever in D.C., I encourage you to come to the museum. And so we had the opportunity to run a study on the museum floor where we would go and ask visitors whether they were willing to participate in our study. And they had a little scenario where they were asked 2 questions on the basis of translation, some of them that were correct, some of them that were incorrect, and to try to figure out whether they were able to compensate for errors and see how they dealt with errors. Fun thing about this is that these are lay people, including kids, including older people that we would not have access to on Prolific, and they had a wide variety of proficiency in the languages of the study, with Spanish translation into English. And to our surprise, what we found is that none of the visitors, if they were not bilingual, they had no idea how to deal with the translation outputs, how to evaluate them, how to get a feel for whether the translations were correct or not. We thought, oh, people who had a little bit of knowledge of Spanish might be looking for cognates or something, like they might come up with strategies. Also, keep in mind is that people who are choosing to spend their time at a language museum, right? But even these people had a really hard time figuring out how to assess translation outputs. And so, that led us to think about, well, what can we do in terms of like NLP solutions to help them develop what we're thinking as AI translation literacy. And we don't have a solution yet, but we have like one baby step, and that's work that we'll be presenting this summer at ACL, where we use questions and answer again, a little trivia game where people have to choose when to rely on automatic translations and when to ask for human translations. And there's like rewards set up so that they're rewarded if the answers to the questions are correct, but also they don't over rely on the human translation. So they need to learn to balance relying on the automatic translations and relying on the humans. And what we found is that with these little games, people were able to develop better mental models of what machine translation systems can and cannot do if they have a little bit of knowledge in the languages involved. If they don't know anything about the source language, they still struggle. So there's still a lot of work to do in that space, but I wanted to highlight this as an example of technical work that we can do to support communication in casual use settings as well. Okay, so I've talked a lot about translation because, I just cannot help but think about translation. But communication is, of course, much broader. And so I'd like to take a little bit of time to think about other tasks, and in particular, to think about communication in cross-cultural settings. I think to some extent, we're seeing a little bit of the same story as with translation in cross-cultural work today. There's a lot of work on static benchmark and testing for knowledge gaps, which is very important. But this remains in vivo benchmarks, and there's not as much work on more like in vitro benchmarks. There's not as much work on in vivo evaluations of how AI tools can actually support communication across cultural gaps, and to what degree they succeed or fail. So in that space, some questions we've been asking is how attuned are large language models to cultural knowledge in open-ended generation tasks? So our goal here is to test the cultural competence of models, which requires cultural knowledge, of course, but goes beyond that. And the task we decided to work on for this was to ask models to generate descriptions of artworks that are targeted at audiences for different cultures. So, we think artworks are a good use case for this because, they encode rich cultural meaning, symbolism, historical narratives, but they're really explicit. Like, it wouldn't be great art if it spells out what the symbolism is, but culturally attuned audiences are able to make these interpretations very easily. So, for instance, if you can look at this picture of this artwork, this is a lotus cup from the Qin Dynasty. You can describe it with the bulb mimics a lotus flower, and it's on top of a seed pod base. But if you're not familiar with Chinese culture, you might not know about the symbolism associated with this lotus flower, which represents purity, enlightenment, and rebirth. So that's why there's all this meaning associated with the lotus cup beyond, it's pretty. And we're interested in this as a generation task because it lets us test the pragmatic competence of models that is crucial in communication. Here, generation needs to anticipate differences in shared knowledge. What is it that we can take for granted for a given audience? What is it that needs to be explained? And that's necessary to minimize miscommunication from all the works in pragmatics that we can draw on. So to do this, we had to build a new benchmark that we used open access images from the Art Institute in Chicago. We curated a smaller, we have a lot of data, but we curated a smaller test set for the experiments I'm going to show you that they have about 280 artworks focusing on Americans and Chinese artworks. And the task is, given the image of the artwork, as well as its title, the name of the artist, and the date when it was produced, generate a text description for an audience that is either American or from the Chinese cultural group. Right, so it's pretty straightforward generation task. As always with open-ended generation, sometimes or as often, the evaluation can be harder than the generation task itself. And so here, to evaluate, we decided to focus on multiple choice comprehension question, right? The assumption here is that a good description is one that lets the audiences understand the artwork well, and so we can test that with comprehension questions. We generate these questions automatically. Again, we cannot do this naively. You need to extract cultural symbols from the images first, then generate questions. We generate both culturally attuned questions and culturally agnostic questions as a control. In terms of validation, we had people answer these questions just on the basis on the image and the basic title information, and people of different backgrounds. And we found like overall the questions were hard to answer without any context. Like the best accuracy we had was like 57%. But crucially for us, the people who answered the questions that match the background were easier to answer than the questions that don't match the background. And so that's what we want to test, right? That tells us that these questions are useful for what we want to test, measuring the difference, measuring whether targeting the descriptions to a specific audience is useful. Okay, so in terms of approaches, we also played with two different strategies. The baseline is just given the artwork, context, the target cultural group, generate a description. But at the same time, we can draw from pragmatics and like recent large language model work that's inspired by the Rational Speech Act framework, which tells us that explicitly modeling the audience, explicitly modeling not just the speaker but also the listener comprehension, gives better outputs. So in this case, what that means concretely is that we have the base model that generates a bunch of candidate descriptions, and then we're going to have a speaker model that's going to score them from the perspective of the audience. And so that helps us select a better candidate than we would have based on the base speaker model now. So here's what happens when we have a fully automatic evaluation. So here we have LLMs prompted to answer the comprehension questions from different perspectives. And we see that the pragmatic descriptions give better answers than the base model descriptions in unfamiliar settings, which is kind of encouraging and what we hope to see. When we ask humans the same questions, this is a smaller, this is an evaluation of a smaller scale naturally. And so the way it's set up with humans is that we first ask them to answer questions without any description, then with one of the base description or the pragmatic description. And then we show them the two descriptions and we ask them to compare them to see which one they like better. And we find that they like the pragmatic descriptions better, no matter their cultural background, both in terms of comprehension. It helps them understand the meaning of the artwork better. It helps, it describes the explanation of cultural symbols they don't know better. And it actually also provides that explanation of symbols they're already familiar with. In terms of accuracy in question answering, we find that all the descriptions help understanding, and it helps more for the artworks where that audiences are less familiar with. But in this case, the differences between the pragmatic and the base models are not significant. So, there's clearly more work to do in this space. Both we would like to scale up this evaluation on the human side. But I think what we're already seeing is that the pragmatic modeling is promising. It does not solve the gap, so there's more work to do in modeling in terms of targeting the explanations to audiences of different cultural backgrounds. And also, we need more human evaluation here to complement the automatic evaluation in the cultural space. we're not seeing the same thing. And so the LLMs cannot replace the humans here in terms of evaluation. Okay, so I'm not going to, there's a lot more in the paper, which is work led by Lingjun Chao that you can find on arXiv, and we're still working on it, so feedback on this work is very much welcome. But for now, I just want to highlight this task that we're calling ArtBridge, a new task for culturally adapted text generation and an evaluation framework for pragmatic competence. All right, so to wrap things up, so I started with this question, right, that motivates a lot of my group work. When AI mediates communication across languages, to what extent does it generally help people understand each other? And I have not provided a full answer to this question, right? I've provided some elements of answers, what it looks like in some specific settings, but I think they highlight possible paths, and by no means not the only paths, but possible paths to solutions, moving beyond static benchmarks towards in vivo evaluation of real communicative success, and reframing language generation from maximizing producing a sequence of tokens that maximize probability given an input, to designing scaffolded interaction that can support building common ground. The challenge, of course, is that there's a very wide design space here when we're thinking about like what scaffolded interaction looks like. And there are also so many possible use cases. And when we do like this kind of very human-centered work, it's like important to ground in the specific use cases and design for that use case. But at the same time, as an engineer, I'm always asking myself, well, like, we need generalization, right? We cannot like custom design the solution for every possible use case. So there's a real tension here, and figuring out how we can generalize while supporting the needs of people in specific use case is I think, a pretty challenging problem. At the same time, I think there's a lot we can learn here from interdisciplinary perspectives. We don't have to start from scratch and treat these only as a technical problem. There's a strong foundation we can build on, in human-computer interaction. We've learned a lot from translation and interpretation studies in our work, as well as psychology, and of course, communication with experts in the use cases. So, I think the stakes here extend well beyond translation and cross-lingual communication, as AI agents mediate more and more of everything we do, from how we work, teach, decide, connect, everything. I think getting this right really matters from human-AI interaction broadly, and not just across languages. So I'll stop here and welcome your questions, comments, and thoughts. Thank you.
Thank you so much, Marine. This was a wonderful journey through machine translation to cross-cultural communication. Thank you really so much. I think there was a lot of like different pieces of information and like ideas that you just dropped like started spinning to ideas like in the listener's brain. So maybe we can take it like first talk a bit about the first MT part, and then move more to the later cross-cultural work that you presented. So I'm going to start with the questions from the chat, but then people can already start raising their hand now, specifically for the MT part, or like the more MT focused part, let's say. So we can start there. So we have a lot of questions from Karan saying, thank you so much for being such an active listener, active question asker. So I think the there was a question about do you see a path towards combining QE and back translation into hybrid interface to get to the best of both worlds? So I think that was building on the observation that back translation performed pretty well with actual practitioners, but then not so much in the WMT evaluation.
Yeah, absolutely, right. I mean, I think, there doesn't need to be one solution. In some way, I think the question generation and answering as a layer we add on top of back translation. In the experiments we've done, we haven't shown it jointly with the back translation, but there are lots of questions in terms of interface, like what would it make sense to show to people in which settings. Like there are settings where if you're a doctor in the ER, like you probably don't want to be overwhelmed with like a lot of stuff to look at. But I can imagine other settings where people are happy to, look at more text. So I think there's definitely a lot to do in that space in terms of like interfaces and figuring out how to effectively combine different types of signals.
Yeah, I think there was a second question, similar direction. So about AI explanation versus like the question answer option. So Corin asked whether do you think that its success comes from giving users objective or cognitive evidence rather than an AI subjective opinion like the LLM explanation. So do these question answer options seem more objective than AI?
Yeah, so I think it's an interesting way to think about it in terms of objectiveness. So in some ways, I hadn't thought it in terms of objective subjective, because at the end of the day, everything is AI, right? Like the questions, the answers, like this is all LM generated. I think the way I think about it is that when we just give questions and answers, we let people think about, which of these pieces of information matter from their for whatever it is they're trying to achieve, whatever their communication goal is. And so I think in the sense that it uses, the question says cognitive evidence. I think it engages people in the process of thinking about what is the impact of the outputs they're seeing and the possible mismatch, much more than, if the LLM gives them an explanation of what the translation quality is, or we give them an assessment of a highlighting of where the errors are. I think in that sense, it engages people in the thinking process more, and I like that from the perspective of preserving some agency for us humans.
Yeah, preserving the ability to think and something. It's a good thing, probably. Should do this rather earlier than later. Okay, I think the other question about the how the questions were answered, how the questions were written was probably answered because the question came before. So unless Karan correct me, does anyone else want to have raise some questions about more MT focused parts of the presentation? So I had a question there. You said doctors are quite expensive, and you start with a crowd, and I thought that's I think the most intimidating thing when anyone talks about or dreaming, or when I'm dreaming about interactive kind of research. So how do you get there's lots of people around us that use AI and all of that, but how do we get to find those that can give us the information that we need for our study? So how do we and it takes time, like you said, this research is slower. So do you have any tricks, any recommendations how to get started if anyone wanted to embark into more kind of interactive communication kind of research where it also requires working with people, which can be quite intimidating because it's very different than working with a computer?
Yeah, no, I mean, I totally relate to that, right? I mean, my background is in computer science and electrical engineering before that, and so human studies is not my comfort zone. I mean, I think what has made this possible for me to work in those settings, and it's still really hard, is to find the right collaborators. So for these clinical studies, we have collaborators both in HCI who know how to design studies, which it turns out is I learned is really hard. With automatic benchmarks, they're hard in other ways, but if you get it wrong, you can rerun it. With a human study, you really need to think through your design and commit to it. And so this is really important expertise. And at the same time, like, we had collaborators who were doctors, like in the medical school at the University of California, San Francisco. And so, they were able, like, they're motivated, like they need help. They need the solution, right? They use translation tool in their practice on a regular basis. So they want to get this to work. And so they understand the problem, and we had and they can help us reach out to people who are willing to take the study, to take the time to do this. And also, I said doctors are expensive, but a lot of the participants in our studies are residents who, are qualified doctors, but are more incentivized to participate in the study than any doctor out there.
Yeah, and I also don't want all doctors to spend their time like fixing AI output. That's probably also not ideal. Yeah, okay. Well, that's a very good advice. I think collaboration is also what we learn in our lab is always very powerful. Can be very, very, very powerful, especially like with open science communities. I have maybe one more question in this direction. So I love that you brought up that users usually don't have an actionable strategy because we don't really design these actionable strategies when, like, we design the model training to be done when the loss is at the point where we're happy with it, and then it's a static model, and like ideally this model is perfect, right? That's the world that we're modeling, and so there's this big mismatch, and so I think it's really a really inspiring thought to like think more creatively with interfaces. So what kind of strategies can we give people, if developers who might know some ideas already? And what was fascinating also is like when you said, like, even when we have quality estimates or when we build confidence estimates, is something that we've done recently in the lab and with our research. Like even when we have those, they might not be actionable enough for the user, or they might not directly be like useful because these are scores, and they are quite technical. They require context, interpretation and context. So I was wondering if you think that like these kind of post-hoc strategies that we add after, should they be part of the initial modeling, like, and like how could we bridge it? It's a very big question. I don't know if you have any thoughts in that direction.
Yeah, so I think, like what we're doing right now is like, it's like, in all of these work is like these big pipelines where we do a lot of stuff post hoc and so on. And wouldn't it be great if we didn't have to do these kinds of complicated pipelines, and if we had models that were natively good at giving us confidence estimates, and interpretability and so on. That I think that might still need some scaffolding on top, right? Because how you communicate what matters to a researcher or a developer building the model is necessarily going to look very different from what you show to a doctor, what you show to someone in the museum or a student, or like, so I think there's always going to be some level of adaptation needed, but at the same time I think there's just a lot more we can do in the core initial model to support these interactions better. So I didn't, I focused more on the human-centered side today, but I'm also really interested in mechanistic interpretability work to understand where multilingual generalization works and fails, and in particular this tension between, encouraging generalization, which is what we want to do. We want to learn from the higher resource settings and transfer that to the lower resource settings, while at the same time preserving the linguistic and cultural specificities, and not have models that kind of like uniformly English and mimic the values of like weird countries. So I think that there's meaningful technical work to do there that has a direct bearing on these human-centered questions. But these are very much open questions. Like I don't have a solution yet for like bridging this kind of work, these two lines of work. But I'm hoping that, you know, as a field, we can get there in the future.
Yeah, thank you. I think you just answered Karan's last question about mechanistic interpretability. I cannot pronounce the word interpretability. Cut this off the recording, please. But yeah, like I think relating that to the model of cultures or the world model of cultures, so in the dissection of like trying to understand how these cultures are being modeled in that art study, did you do anything in that direction?
In terms of what direction do you mean, like the mechanistic interpretability? Yeah. There's the work by one of the students in the lab who's about to graduate, Hyojong Han, who did the mental models work, but also more mechanistic interpretability motivated work. Some of it is from her internship at Google that I was not involved in, but where she looked at steering mechanisms to try to be very specific about like what not, like encourage the transfer of some knowledge but not other. And I think that's very exciting. And she's following that with more work in this direction because, you know, it's just so hard to test with the space of language, the space of cultural dimensions. There are many benchmarks, and at the same time, there's too many benchmarks, and at the same time, they don't cover all the things we care about. So she's taking these ideas further. So I point to work by Hyojong, but this I think is still very much an open question.
Yeah, thanks. We actually chatted with her early in our exploration of cultural, like to kind of get a feeling about like what the steering direction looks like. So that was very informative for our research as well. Yeah, now we ended up in the cross-cultural kind of corner directly. Does anyone have more questions? Also very general questions, more specific to any of the slides or the contents? Go ahead, Ananya.
Thank you so much for your talk. That was so interesting. I guess one question that I have is when we don't have access to like user studies and we want to evaluate communicative-mediated studies, like are there any kind of automatic evaluations that you would suggest looking into, or like how to pick which tasks that should best be evaluated for and approximate these type of real-world communication studies?
I think this is an excellent question, and that's what I'm also grappling with, because you know, like I can't evaluate everything on human studies, and we need like, I think we need a middle ground between like the static benchmarks and the human studies for informing the development of technology. The human studies loop is very informative, but it's slow, and not everyone has access to it. And so, you know, these are some of the things that I'm thinking about. Like I unfortunately don't have yet a specific like metrics or a task I could point you to. But what I'm hoping we can develop, you know, as a field, like I'm engaged in it, but I'm hoping others can join, is kind of evaluation infrastructures where we have a set of tasks that, you know, we can look to psychology for that to think about like what are tasks that test the main dimensions that we care about in terms of communicative success, and then ways to evaluate this success. And you know, on the one hand, you can do that fully with people, but increasingly we can also simulate users with large language models. This comes with a lot of caveats. How to do that responsibly and you know, in a way that is informative is far from easy, but I think that can provide a middle layer with the appropriate scaffolding. So for instance, like right now, we're looking at puzzle tasks where, you know, you put two people or one person, one agent trying to solve a puzzle together. And then these puzzles are designed in such a way that we can look at the interaction logs and track how people refer to different pieces of the puzzle and develop a common ground through these tasks. So it's a super artificial task, right? Like nobody is gonna like build an AI agent to help them solve puzzles. I mean, I don't know, maybe some people do, but that's not a core application area. So these are like a little bit of like artificial settings, but they can help isolate some specific behavior types that we can measure in a way that is automatable, as opposed to like fully open-ended communication tasks. And so like the way I see like bridging this gap in the future is having these kind of like, you know, in the same way we have like LM arenas and so on, like we could have like a set of communication tasks that are set up for interactive evaluation, where you can swap models, people, and so on, and then track like what happens with the interactions and develop metrics on top of these interactions. But I don't have one such framework to point you to, but if anyone wants to help in developing these things, I think that'd be awesome.
Thank you so much. So yeah, we are at time. I think we could still discuss for for quite some time, I think. But thank you so much again, Marine. This was very inspiring, and I love all the creative energy that also came up in the discussion. And yeah, thank you so much, and have a great rest of the day and a good weekend as well. Thank you everyone for joining us here, and see you next time. Bye.